Okay, so now we're going to move on to onto. So what does it mean to be onto? If and only if, for every y, there is an x such that f of x equal y. So again, you start here in the y's. So for every y, I can go back and find an x so that f of x equals y, right? So for every y, you start here, there is an x such that f of x equals y. That's what onto means. So what would not be onto, so let me just start with a and a b, and an x and a y and a z. Okay, so this would be a picture of a function that is not onto. Remember, a function has to act on everything that's in the domain, but it doesn't have to act on everything that's, or it doesn't have to reach everything in the codomain. So this is not onto, right? Because there's no x value, so there's nothing in the x's that reaches that value of z. Okay, so all but 2 of these are correct. All but 2. So find the 2 false ones. I want you to turn it off for a second and think. This one starts in the domain. That's false. This one starts in the domain. That's false, right? So you can't do those 2. Okay. All right, so here's a function, or here's the sets x's and y's. So 1, 5, and 9. Remember, put that numbers on the outside, dots on the inside, so if you're going to be drawing arrows, right? Because I want you to draw arrow diagrams. Oops, let's make that circle a little bigger and nicer. So here's a dot for 3 and 4 and 7. Okay, so 1 goes to 4, 5 goes to 7, and 9 goes to 4. Okay, so is this 1 to 1? No, because f of 4, right, equals, oops, I said that wrong. Whoops. I meant f of 1 equals 4, equals 4, and f of 9 equals 4. So it's the same y value, but 1 doesn't equal 9. It's not the same x value, right? Is it onto? Or is every value in the y have some x value that goes to it? No, right? 3 is an element of the y, and there does not exist, right? There does not exist an x in the x such that, right, f of x equals the 3. So it doesn't exist. All right, so here's a new function. So this was a picture of f. Now we're going to do a picture of g. So here's 1 and 5 and 9 again, and 3 and 4 and 7. So 1 goes to 7, 5 goes to 3, and 9 goes to 4. Okay, so is this 1 to 1? Yes. Yes, it's a 1 to 1, because if I take a g of x1 equaling a g of x2, right, the x1 will equal the x2. So anytime I pick something in here, there's exactly one item going to it, right? Pick something in here, there's exactly one that goes to it, right? So yes. Is it onto? Yes. For every y in y, there is an x in x such that f of x equal y. So that means it's onto. Okay, so let's go to, actually, this one I'm going to have you do. So this will be example 3, yours to do.